Hello again. This is Itsu. I saw the request from physics profs or Joule Seeker to do another test from his special circuit. I put it together again with my 2.2k resistor in the base and the 140 picofarad capacitor in the base. The LED and the 1 ohm and the 3.3 ohm resistor there, and also for this resistor I have the combo of a fixed 5.6k and a 5k potentiometer. So this is the circuit again. This is the potentiometer. The LED is lit a little bit again. I have again this dual multimeter input measurement setup. Would be this schematic. And I also have my scope hooked up over across the 1 ohm resistor there, so I can compare some things. I have hooked up a what is it, a big 1A or whatever, 1.5 battery. Oh, sorry, no, that's for something else. I have hooked up again the rechargeable battery, the AA, and the voltage and current being drawn at the moment is 1.3 and volts. And the current is 13.7 milliamps across the 1 ohm resistor. And that's a little bit strange because in my last video it was 34 milliamps, so I'm not sure where the difference is. I did not change anything in the circuit, to my knowledge. So anyway, this is more in line with physics prof's measurements, I think. On the other hand, I'm also having my probe across the 1 ohm resistor, and this is what it looks like. This thing is getting out heavily RF, so I have to put in a little ceramic 100 nanofarad capacitor across the plus and minus, because otherwise I can remove it and the scope will look like this. I have lots of RF there on the battery, so I put it back. And so this is the current across the 1 ohm input resistor. And when I zoom in a little bit, we have the several values. Frequency is all over the place. But what I would expect that the main voltage would be similar to what the multimeters would show if I put in more of them. But they are higher, 17, instead of what the multimeter shows is the 12.8. So I cannot really compare there. And the RMS is, when I change to 1 cycle, 2 cycles, what is it, 1 cycle, it also stays high. So. But this could be, of course, because of the RF is going out. To show you which RF is going out, I will put it into FFT. And there you can see it's now set in 25 megahertz per division. So you can see all the way up till 75 megahertz, a lot of noise when I remove the plus of the battery, so I kill the circuit. Oops. The first megahertz are gone, so this thing puts out a lot of RF all over the place. I put it back now. So I guess that's one of the problems I get with this. To measure properly with the scope. So I think the multimeter is the one to trust at the moment. So I can make the calculations now, and it's more in line with what Physics Prof has. So the other thing was discussed is that Physics Prof runs this thing on 4 10k microfarad capacitors, as I understand it. Well, I try to. I have also 4 of those capacitors, 10k microfarad paralleled, and I've charged it with a 1.5 battery. But when I attach these capacitors loaded to the circuit, it will die in about 5 seconds. The voltage drops and it's gone. So I cannot make any 30-second measurements as being proposed. So I'm a little bit puzzled about that, why that's not possible here. Or should I have some feedback? So I have to clear that up first. Okay, thank you for watching. Just a little add-on for letting you see what happens when I hook up the 4 10k microfarad, so 40 millifarad totally capacitors, which I've loaded now. It's still at 1.542 volts. I have attached the minus lead already to the minus of my little circuit, and I will attach the plus to the circuit, and I will have to watch what happens on the voltmeter when I touch it, and I will do it now. So you can see how fast the voltage drops. The output is slowly dying. So it won't last for 30 seconds. Oscillation is almost gone. So I'm not sure how to do this capacity 30-second measurement. Surely this is not the way. It cannot sustain the voltage long enough to do my measurements. The circuit is died now at half a volt. If I remove, it will stay there, of course. But so I have to get some information about how to do this capacity loading of this circuit. Okay, thank you. Hello, welcome back. Just a little add-on again about the latest information. I have now put together a bank of 10 of these 10k microfarad capacitors to see if it will last any longer. These are 9. I have another one here. These are aluminium electrolytes, 10,000 microfarad, 6.3 volts. I'll put them together parallel. And I have hooked up this battery. It's only attached to this capacitor bank at the moment. It's been loading now for what is it, 10 minutes or something, and the voltage seems to be stable. So I'm going to attach again. Let me try to get this light out of the way. I have my scope probe hooked up to the collector, to the no, what is it? The top of the resistor is on the leg of the. So it's this point here, 0.22T. So I can measure the output, and hopefully it will It will last for 30 seconds, so I can make the calculations, but as soon as it's going to die, I will stop. I will look at the voltage and note down the second, so I can make some calculation about the input being drawn. I will detach now the capacitor bank. The battery is off. So the voltmeter shows the capacitor bank. I will attach the minus lead at the moment. And I will have these meters and the scope together to see what's happening. I'll try to make some measurements. We'll start now. So you have nice output. We have 9 volts going down now already. The voltage starts to decrease. The current also. It's now 15 seconds. It's still running. Around half a volt it will stop. 20 seconds, not 25 seconds, 30 seconds. Okay, 522. It's 522 millivolts. It was after 30 seconds. But you can see it's still running, kind of. The current is very low. It will start to die out now. So even with my 10 times 10k microfarad capacitors as 0.1 farad, it will not last very long. It's stopped now. So that's what I'm trying to show you here. I will make now again the calculations, but my power input must be somewhere in the what I saw before in the 10 or 13 or no, what was it, 18 milliwatts, and not the microwatts that Physics Profs is showing with these 4 capacitors. So I'm not sure where I'm going wrong at the moment, but it's I've shown it's not working at my place at the moment. Okay, thank you for now.